The universe is always getting bigger, so it's tough to say where it ends or how big it is. But now, with the James Webb Telescope, we can peek way out there. Brian Cox and other scientists are saying the universe is bigger than we can really imagine. In the part of the universe we can see, there are about 2 trillion galaxies. That's just based on what we've seen nearby. The part we can see is probably just a tiny bit of a possibly never-ending universe. We're not separate from the universe, we're part of it. We're like the universe's way of knowing itself. The James Webb Telescope is helping us check out the size of everything. If you want news about space and stuff, subscribe to our channel. Like this video and hit the bell. If you drove around Earth at 70 miles per hour, it would take you about 15 days. The Moon is 5 months away, Mars is 63 years away, at its closest, and Neptune is a crazy 4,400 years away. That's just our solar system. Voyager 1, which launched in 1977 at 38,000 miles per hour, didn't leave our solar system until 2012. That was 35 years just to get out of our neighborhood. Even light, which can go around Earth 7 times in a second, seems slow compared to how big our solar system is. But our solar system is nothing compared to the Milky Way galaxy, which has about 300 billion stars, each with planets probably. Our closest star, Alpha Centauri, is 4.3 light-years away. So, even at the speed of light, it would take 4.3 years to get there. Imagine getting to Alpha Centauri. If something went as fast as Voyager, 38,000 miles per hour, it would still take 70,000 years. That shows you how far away things are in space. Let's talk about Velta Rouge, a star 640 light-years away. Our radio transmissions have only gone about 100 light-years. So, they've reached about 15,000 star systems, but there are billions of stars in the Milky Way. If you see Rouge tonight, you're seeing light that left it 640 years ago, before Columbus sailed. That light has been traveling all this time to get here. It's amazing that Velta Rouge is actually pretty close in space terms. Our radio waves are just a tiny dot in the Milky Way. If our solar system were the size of a quarter, the Milky Way would be as big as the United States. And in that area, there would be 300 billion star systems with planets. We're just one of those systems. Beyond our galaxy, there are at least 1 trillion other galaxies. 1 trillion is a lot. Our closest galaxy, Andromeda, is 2.5 million light-years away and coming at us fast. It has 1 trillion stars. When Andromeda crashes into the Milky Way, which has 300 billion stars, the stars probably won't hit each other. Space is just too big. Galaxies are always moving and changing. Beyond our galaxy is the Local Group, then the Virgo cluster with over 1,500 galaxies. Virgo is part of Laniakea, which has around 100,000 galaxies. Each of those has billions of stars and planets. And that's just a small part. In the observable universe, there are 10 million similar superclusters. We've mapped a bunch of galaxies, but there are hundreds of billions more that we haven't. There's also the cosmic background radiation, the oldest light we can detect from the Big Bang. Beyond the galaxies, there are cosmic voids, spots where there's not much stuff. They're huge, like millions of light-years across, and seem empty. But they could become new galaxies later. Then there are cosmic filaments, giant threads of dust, gas, and dark matter that connect galaxies. They make a web-like thing that holds the universe together. Space is where all sorts of stuff happens. Stars explode as supernovas, scattering elements around. Black holes mess with galaxies and shoot out energy. Quasars, big black holes, eat stuff and shine super bright, helping us see the early universe. What's beyond the part of the universe we can see? There are probably more galaxies, but their light hasn't reached us yet. Because space is getting bigger, we might never see them. The whole universe could be 250 times bigger than what we can see, maybe even infinite. Thinking about this makes you wonder what we're doing here on this planet in this big universe. So, ever wonder how big the universe is? I hope this video helped a bit. Leave your questions in the comments. If you liked the video, hit the like button, share it, and subscribe. Thanks for watching. We're always learning more about the universe. New tools like the James Webb Space Telescope are opening up possibilities we could only dream of before. They help us see the early universe and check out planets around other stars to see if there's life out there. We've found thousands of exoplanets. Some are in the habitable zone where water, and maybe life, could exist. Some are like Earth, others are gas giants or icy with oceans. There are probably billions of these planets, so life might not be that rare. But even if we don't find life, the universe is full of mysteries. There's dark matter and dark energy, which make up 95% of everything. Dark matter pulls on stuff but doesn't shine. Dark energy is making the universe expand faster. We don't really know what either of them are. Some scientists think there's a bunch of universes, a multiverse, each with its own rules. They might be separate or connected in weird ways. It's just a thought, but it's mind-blowing. Time is different in space. It slows down near big stuff like black holes. So, time on a space station near a black hole would be slower than on Earth. This affects space travel and how we think about space and time. Black holes aren't just cosmic trash cans. They're powerful. Big galaxies have black holes millions or billions of times bigger than the Sun. They shape galaxies, control star making, and shoot out jets of energy. There are also wormholes, shortcuts through space that could connect faraway places or even different universes. They're not real yet, but they're cool to think about. With all this craziness, we're just a species on a small planet, orbiting a regular star, in a quiet part of one galaxy among trillions. But we can ask big questions, build telescopes, and imagine stuff beyond what we can see. Every picture from a telescope, every radio wave, every particle we find helps us learn more about space. We're slowly figuring things out. When we look at the night sky, we're seeing the past, the structure of space, and mysteries we haven't solved. The universe is super big, but it also shows how curious we are and how much we want to explore. In the part we can see, there's maybe 2 trillion galaxies. That's just a guess based on what's nearby. What we see is probably nothing close to what's really out there. We're part of the universe, not separate from it. We're how the universe gets to know itself, in a way. The James Webb Telescope is helping us check it out, and try to work out the real size of everything. If you want to know about space and stuff, subscribe to our channel. Like the video and hit the bell so you don't miss anything. If you drove around the Earth at 70 miles per hour, it'd take 15 days. The Moon would be 5 months, Mars 63 years, and Neptune about 4,400 years. That should let you know how big things are. Voyager 1 launched in 1977, and has been traveling at 38,000 miles per hour. It didn't leave our solar system until 2012. That's 35 years to get out of our neighborhood. Light, which goes around the Earth 7 times in a second, seems slow after that. The Milky Way galaxy is way bigger. 300 billion stars, and planets going around pretty much all of them. The closest star to us, Alpha Centauri, is 4.3 light-years away. So it'd take light about 4 years to get there. Think about getting to Alpha Centauri at 38,000 miles per hour, like Voyager. 70,000 years. That's how much it takes moving in space. There's a star called Velta Rouge, 640 light-years off. Our radio signals have only gone out about 100 years. They've hit 15,000 star systems, but not a large percentage of the Milky Way. When you see Velta Rouge tonight, you're seeing light that left that star 640 years ago. Before Columbus sailed. The light has been traveling to our planet for a long time and only a little bit of that light is reaching us today. Velta Rouge is actually very close to us. If the solar system was a quarter, the Milky Way would be as big as the United States. 300 billion star systems are in that space. Then there's at least 1 trillion other galaxies. 1 trillion is 1 million times a million. That's a lot of galaxies. Andromeda, our closest galaxy, is 2.5 million light-years away. It's zooming toward us. When it gets here, the night sky is going to be different. It has 1 trillion stars. It won't be a problem, even with us only having 300 billion. Space is big and they are not going to hit each other. Galaxies move and change. Outside our galaxy is the local group, and the Virgo cluster of 1,500 galaxies. Virgo sits in a supercluster called Ionia, with 100,000 galaxies. All of them got billions of stars and planets. And that's a small part. In the part of the universe we can see, there are 10 million superclusters like it. Most of the galaxies are not mapped. There is cosmic background radiation. It is the oldest light, heat from the creation of the universe. Space beyond the galaxies is huge. It contains cosmic voids where there is not as much matter. These voids stretch hundreds of millions of light years. Cosmic filaments are in space too, which is made of dust, gas, and dark matter. They stretch billions of light years, and connects galaxies and clusters. The universe is connected to each other by the gravitational interaction. Galaxy clusters interact by gravity. Supernovae and black holes also exist. Supernovae spread stuff around when big stars die. Black holes are also important. Out there in the depths of space, we get things like quasars, giant black holes that give off crazy amounts of energy. What is beyond what we can see? Plenty more of these galaxies we can't see, because the light has not traveled that far. Because the universe is expanding, we might not see these galaxies. From what we know of physics, we think it's at least 250 times bigger than the part we can see. It potentially might be infinite. It causes you to consider how we fit into the universe. Have you thought about how big the universe is? I am hoping the video helped you understand it. Post your questions in the comment box. If this video helped, like it, share it, and subscribe for more video. As we keep looking into the universe, keep in mind our view of it is. New inventions like the James Webb Space Telescope make things possible. These tools are allowing us to research the early universe. Are we the only ones in the universe? Astronomers has discovered thousands of exoplanets around stars far away. There are Earth-like planets that are the right size. Numbers of these planets might mean that life isn't that rare at all. Beyond the search for life, the universe has tons of mysteries. Dark matter and energy makes up about 95% of the stuff in the universe. Dark matter helps explain how galaxies move. Dark energy is the reason the universe moving so fast. Some physicists think that our universe could be one other universes. These universes are disconnected or higher up. It gives an idea of what is there. Time is also. Einstein's relativity says time moves differently for massive objects. On a space station close to a black hole, time moves slower. Space travel says that. Black holes aren't the vacuum. They're engines. Pretty much every big galaxy has one. They can evolve galaxies. Wormholes are still theoretical, bridges through space. We can ask question and build machine to explore.